How uncertain do you want to sound? In this video, we're going to talk about how to be precise about uncertainty. I'd like to acknowledge that the content of this video is virtually verbatim from Peter Sandman's essay on acknowledging uncertainty. Absolutely certain statements about risk are almost by definition wrong. Like any scientific statement, a risk statement has to be qualified in principle by the possibility of new data, new information arriving. The full range of science is from almost impossible to almost a sure thing. So when the topic is a controversial risk, of course, the most sound statements are closer to the middle. Sources who don't want to say anything until they're certain will seldom have anything to say. Saying you're uncertain, in other words, is a good start, but it isn't enough. Your goal should be to communicate as precisely as you can what you think so far and how uncertain you are. Perhaps the best way to say how uncertain you are is to say it with numbers. If you have a statistical estimate of the probability of some outcome, give it. Even without defensible statistics, numbers can help clarify your hunch. Though of course it's important to stress that a hunch doesn't magically turn into valid quantitative data just because you choose to express it in numbers. In other words, you still need to be clear about how certain or uncertain your estimate of the uncertainty is. But we live with numerical hunches all the time. Everyone knows what a guesstimate is. Everybody knows the guesstimated odds of 1 in a million mean it's not going to happen. 1 in 100 means it's a real long shot, but it could happen. 1 in 10 is still unlikely, but nobody will be surprised if it does happen. 9 in 10, 99 in 100, and 999,999 in a million are similar seat-of-the-pants estimates at the other end of the probability distribution. We all know what 50-50 means too, but in this case it's important to clarify whether you're saying that the evidence is pretty evenly divided or that there isn't any relevant evidence on which to base a judgment. In the absence of numbers, you can do a lot with words. We can't prove X conclusively sounds like you're fairly sure X is true. We can't rule it out conclusively sounds like you're fairly sure it isn't true. Both acknowledge uncertainty while sending clear signals which side you think the smart money is on. We have no evidence of X also sounds like you're fairly sure X isn't true. This is a favorite expression of corporate spokespeople, and it's often used to mislead. If there have been no studies looking for a link between dimethyl meatloaf and pancreatic cancer, the claim that there is no evidence of such a link is technically accurate, but intentionally misleading. If there have been lots of relevant studies and none of them found a link, you'd naturally want to back up your claim by saying so. There are phrases to match any level of uncertainty. They may be wordy, but they communicate clearly enough. The weight of the evidence suggests that X is likelier than not, but there's still plenty of room for doubt. We're almost sure that X is not happening, and we are proceeding on that assumption, but we're continuing to monitor the situation, so we'll be able to change course if it turns out we're wrong. We think it's probably X or Y. Z is less likely, but still a contender. We'd be shocked if it's anything else. Being precise about uncertainty is easy enough to do, especially if you set out to clarify in the mind of the audience exactly what's in your own mind. You can usually come up with language that does the job. The problem is we don't often try to do that, and there are at least 4 biases that keep us from trying. Those biases will be the topic of this and the next 3 slides. The very first bias is the bias against sounding ignorant. In some ways, the most important uncertainty claims are the ones that provide no guidance whatsoever except the crucial information that there is no sound guidance available. Statements like, I have seen the studies that suggest these chemicals might cause birth defects in mammals, and other studies that show no such effect even at high doses. The evidence is mixed and very confusing. Those kinds of statements are far rarer than they should be. Experts don't like to sound ignorant, so they don't often flat out say they don't know something. They focus instead on what they do know or what they think they know. Reporters are much the same. They like to feel and sound in the know, so they avoid reporting that they couldn't find something out or that their sources didn't seem to know the answer. And so this could be a rationale for being willing to speculate some, because if you decline to say something to a reporter because you're not sure, they're going to find some less scrupulous source instead. So help them understand the uncertainty and proclaim it. There is a bias against being precise and assertive about uncertainty. When risk experts and risk managers do acknowledge their uncertainty, they tend to do so vaguely. It's almost as if the acknowledgement were somehow shameful, as if they felt they ought to be more certain. What's called for is really proclaiming uncertainty. That would be a paradoxically confident assertion of your absence of confidence. Part of the job is to be more precise about your uncertainty. Tell people what's pretty sure but not absolutely sure. What's a hunch, but you wouldn't bet the farm on it? What's a wide open question and what's a long shot? And part of the job is to be precise with flair. Offer as ringing a declaration of your uncertainties as of your certainties. Maybe then journalists would publish the uncertainties too. There's a bias towards sounding more certain than we are. This is the core of the problem. Even when they do try to be precise about their level of uncertainty, risk experts and risk managers tend to round off in the direction of greater certainty. If they're 60% sure, they end up sounding 90% sure, or they simply don't talk about the things they're only 60% sure of. At its worst, the result is a dangerous dichotomy. If it's too uncertain to say with near certainty, you don't say it at all. If it's too important to leave out, you say it with more certainty than it deserves. Scientists rightly complain that reporters tend to make them sound more certain than they are, by downplaying caveats, for example. Scientists are less likely to notice that they also tend to make themselves sound more certain than they are, especially when talking to non-scientists. Many experts who are a model of tentativeness when they're addressing their colleagues become markedly more dogmatic when talking to the rest of us. When most scientists sound overconfident, science itself can end up sounding contradictory, arbitrary, and self-serving. Two researchers looking at different aspects of the same problem report results that trend in opposite directions. They may know and respect each other's work and share a sense of the complexity and uncertainty of the larger issue, but when they talk to the media, they focus on their own findings, and what little they say about the uncertainties is less than quotable. So what we need would be people who are more willing to speak about the uncertainty that does exist with an issue. The fourth and final bias that gets in our way is a bias toward overreassurance. Optimistic bias is a fundamental human characteristic. Research has documented that most people think that they are less likely than others, and less likely than they actually are, to get cancer, to get mugged, to get fired, and so on. There's a contrary tendency called defensive pessimism, but optimistic bias is the real biggie here. So risk experts and risk managers, like most of us, see the world of risk through rose-colored glasses. Likely bad outcomes tend to be seen as not as bad as they really are. Unlikely bad outcomes tend to be seen as even more unlikely than they really are. Uncertainty, in other words, isn't symmetrical. We don't just come across as more certain than the situation justifies, we come across as more optimistic as well. And this state of affairs lasts right up until the bad outcome is too obviously imminent to ignore. And that's when the general public switches to the other side and overreacts, rehearsing for the crisis to come by imagining that it's already here. And that's when risk experts and risk managers experience the strongest temptation to keep on over-reassuring, no longer because they're feeling optimistic, but because they're under pressure. So the pressure to over-reassure comes from all sides, from management, from peers, politicians, affected industries, from the public itself, from our own inner fears. When we're facing serious risks, they over-reassure us because they fear we might panic. When we're facing tiny risks, they over-reassure us because they fear we'll seize on any admission whatever to keep on worrying about nothing. There's a fifth bias here, but this one's on the public's part, not the source's part, so we treat it a little bit different. And it's critical in deciding how to cope with the other four biases. When people belatedly find out that a company or government agency has been overconfidently over-reassuring, they become mistrustful and alarmed. In fact, even before they find out, people often react to overconfident, over-reassurance in accordance with that risk communication seesaw. They smell a rat and they become mistrustful and alarmed. So they go from overconfident to overreacting, to overconfident to overreacting. Overconfident over-reassurance routinely backfires. So here's what you want to do. Step one is decide what you think and how uncertain you actually are. Step two is review these 5 biases and decide again what you think and how uncertain you actually are. Then step 3 is to choose language that captures what you've decided and use that in your messaging.